My name's Luke Cranford. I'm with Joel Boyett and Mason Scott, and we're going to talk about the process of casting a propeller used for large ships.
Here, I'm Mason Scott. This is a couple examples of the type of propellers we're talking about. These are typically found on your large oil tankers and cargo ships that are going from continent to continent, carrying trade goods, things like that. The design of the propeller, it has to be cast in one solid piece because if there's any seams or anything in it, it'll affect the efficiency. And as you can imagine, the efficiency on these ships is very important. They also have to be lightweight. For as heavy duty as they are, they have to be lightweight to maintain that fuel efficiency, as I mentioned. They also have to be incredibly durable because the lifetime of these propellers, they're expected to last over 1.4 million miles seafaring. The composition of the alloy used in these propellers is predominantly copper, about 80% copper in most cases. The other metals they use are typically aluminum, nickel, iron, and zinc. They specifically chose these metals because the blend of these metals creates a very tough, durable alloy that can withstand all the forces that are going to be thrown at it out there in the ocean, while also maintaining that durability that we mentioned. And these metals were also chosen because they need to be cast into this mold, and they need metals that will take the shape of the whole propeller, because as we mentioned, they can't have multiple pieces of the propeller just stuck together somehow. The foundry that is required to heat these metals up to liquid is actually is heated to an excess of 1,800 degrees Fahrenheit.
Yeah, so like Mason was talking about, this must be cast in one solid part. So they do this through a sand casting process. And sand casting has a few parts, but we're just going to highlight some of the main ones. So the first step in the process is to create a pattern. And for this propeller, it's done using wooden planks, as shown in the picture on the right. These planks are put together using glue, screws, or just any other method to fasten them together. And it's created in the exact same shape as what the propeller is going to be. And so once this pattern is put together, it's inserted into the mold, and it's covered with sand. So sand totally covers every piece of this pattern. So there's no air left in there. There's no other extraneous materials. It's just the pattern and sand. And then, so once the pattern and sand are in there, a hole is usually placed in the sand just for a pouring area, and then also another area so that once the pattern's been full of metal, that a little bit of the molten material begins to ease out. So you can tell when you need to stop pouring. So once the pattern is inside the sand and everything is packed in, the pattern is carefully removed, leaving an open cavity in the exact shape of how the propeller pattern should be. And so once you have this cavity in there, you heat up, like that's what I'm saying, you heat up the metals to over 1,800 degrees, so they are one solid liquid. And so once the liquid is the right consistency, it's poured into the mold. And enough is poured in so the entire pattern is full. And like I said earlier, a little bit of the material begins to ease out the top. And then after that, it's allowed to cool and harden for 5 to 6 days in this scenario. So once it's hard, it's able to be taken out of the mold, and then any excess or debris just from the sand, just because it's so hot that there's some stuff that sticks to it and it all needs to be removed. So using a hammer or a chisel, in this case, since the propeller was so large, an excavator, any excess debris was removed from the actual solid propeller part.
Hey, this is Joel. So as Luke and Mason were both saying, this mold is casted into one big piece. So as it comes out of the mold, all of the sand and stuff sticks to it, and it's really hard to get it out with getting all that stuff off. So so they have to grind it down and get it as smooth as possible, because as Mason was saying, the ship travels 1.4 million miles or more. So the propeller really needs to be very efficient, because as it travels through there, it'll get real beat down by the ocean and stuff. So it's as you can see in this picture, it's grinded down by an automated milling machine. This gets it as smooth as can be with no bumps and no errors. So the propeller needs to be as smooth as it can be. So when it travels, it's very gas efficient because this saves the cost on gas and all that good stuff. And they have to add a yellow material to it. This is anti-corrosion. As you can imagine, traveling in the ocean, the salt's pretty high. It corrodes it down a good bit. So without this material, the propellers wouldn't last near as long. They're supposed to last ideally up to 25 years. So without this anti-corrosion, they'd corrode pretty fast, and they would only last about half the time. So here's a final picture of the propeller. You can see how smooth it looks and how shiny and all the yellow anti-corrosion stuff on it. So with all this, it ensures a very efficient propeller.
Yeah, and then from this point, you can see it's on land still. And so it's a big process to actually lift the ships up to be able to attach propellers to the bottom of it. And that will take another week or so before the propellers are actually in use. And so thanks for the time for listening and watching our video. Here's some of the references we use to get the information to make this PowerPoint. Thank you again for your time, and I hope you have a good day.